I'm working on an Enterprise Ireland funded project called an Energy Aware Adaptive Scheme for Multimedia Devices. So mobile devices, and mobile devices can include smartphones, they can include laptops, they can be anything that you'd have in day-to-day use now. And what I'm looking at doing is for very energy intensive applications such as video streaming, I'd look at changing the quality of the video, maybe the brightness of the screen on the device. You could even do region of interest encoding and decoding. And I'm also looking at multi-hop communication as well. So if you have one device that is very far away from an access point, and you have say a laptop that's significantly closer, you could transmit your data from the phone via the laptop to the access point, in the interest of saving energy. So my research is combining all of these different approaches, and a few more as well, and coming up with an algorithm for doing it intelligently. So now I'll show you how we measure the power consumption on the mobile device. We're using this Arduino microcontroller over here, which is logging the voltage drop across the resistor, and it also has the supply voltage of the mobile phone attached in as well. So from those three inputs we can get the power consumption on the phone, which is plotted as a graph, a real-time graph over here on the screen. At the moment the phone is in standby, but you'll see if I press the power button, the graph will immediately become more active, and the power consumption jumps up as well. In fact, the power consumption will be significantly increased whenever I touch the screen on the phone like that, and then if I'm not touching the screen, then the power consumption drops back down. Now I'll start up an application that plays out a video on the phone, but does so at 5 different levels of brightness. What's happening is that off this Raspberry Pi board over here, we're going to play some high definition video. The board costs about $35, and you can install your own version of Linux on it. So this one is running Debian at the moment. So I'll start the demo. This is Blu-ray quality 1080p, a H.264 file. So as you can see, it's flawless. So that's another board that we're looking at, and one of the things that we may do in future is wireless video streaming with it. We can use it as a battery operated server by plugging in a wireless dongle into it. It's very customizable. It has an awful lot of input and output ports over here, on the edge of it, along the top. These can be used for similar functionality as an Arduino, which means that it could be used for image recognition in real life scenarios, or it's basically like a high-powered microcontroller, like a high-powered Arduino. So it's a lot more versatile, and as such it's really very, very flexible for the future applications.